Hey all you analysts, developers and data scientists, we're back with a brand new course as part of our new series on machine learning. We're going to kick things off by building your first classifier model in Python. The goal of this course is to take you from zero knowledge to building your very own classification model in Python. You don't need any prior knowledge of machine learning. A little bit of Python ability would help, but it's not necessary. We're going to cover a little bit of the theory, but mostly we're focusing on the practical implementation of the modeling process. In this video, we're going to look at the main types of machine learning, discuss some of the different terminology used, and then finish with a quick test just to check you are paying attention. I'm John, one half of Pinata Data. We're two data scientists with over 10 years of practical and theoretical experience across the retail, gaming, banking, and tech industries. With that all said, let's get started. Types of machine learning. A quote from the father of computing, Alan Turing. It seems probable that once the machine thinking method had started, it would not take long to outstrip our feeble powers. Not even 100 years ago, statements like this were made, and now computers are capable of crazy feats such as classifying hundreds of thousands of faces a minute and learning patterns on their own that even humans can't see. We're going to use the three paradigm approach to categorize machine learning. There's supervised learning, which uses structured, labeled data to learn a pattern and then predict an outcome. Unsupervised learning, which uses unlabeled, maybe more unstructured data to find patterns. It doesn't use predefined labels. Reinforcement learning finds an optimal policy by trying things over and over again in slightly different ways until it finds the best way to do it. A different way of thinking about this is supervised learning takes training data with a known outcome and tries to predict the same outcome on new data. Unsupervised learning finds hidden, previously unknown patterns in the data. Reinforcement learning is the computational equivalent of learning by trial and error. An example of supervised learning would be something like linear regression, where you try to predict house prices. An example of unsupervised learning would be to segment customers into groups for marketing purposes. An example of reinforcement learning is a computer learning to play a video game from scratch, where the success criteria is finishing the level. Reinforcement learning, I always think about in terms of Mario, which is it figures out, oh, when I press the right button, he runs to the side, but I run into a mushroom. That's not good because the success criteria is to finish the level. So it just keeps doing things until it figures out the way to get success. Today we're focusing on supervised learning. Supervised learning is using labeled data to make a prediction. Without correct labels, we can't predict what the proper output should be. Good data is key. We can break supervised learning down into two further categories. Classification and regression. Classification attempts to predict a label from two or more discrete classes. It finds a decision boundary to separate the classes. Regression, on the other hand, attempts to predict a continuous class. It looks for the line of best fit. We're not going to focus on regression today, we're only focusing on classification. This is an example of the decision boundary to separate the blue class from the orange class. But first, we're going to cover some of the terminology and naming conventions used in machine learning and data science. Three of the most commonly heard terms in data science and machine learning are feature, algorithm, and target. A feature is the data we use to learn from and to make predictions from. You might also hear them called independent variables or predictor variables. An algorithm is the learning process that translates the features onto the target. It's also called the model or the learner. And then finally, the target is the variable that we wish to predict. You may have heard it called the label, the dependent variable, or response variable. You're going to hear a lot of different terms across the industry. There's a lot of variety depending on your background. So it's good for you to know the different terms just so you know what other people are talking about. So we're going to use feature, algorithm, and target. We've covered the basic definitions and a few different terms. Now we're going to check if you've been paying attention. Can you identify the classification problems? Which of these problems are classification problems? 1. Predict a stock price next week. 2. Diagnose if a patient has an illness. 3. Predict if a stock will be more valuable next week. 4. Predict the temperature next week. 5. Predict if it will rain or not next week. And then 6. Predict if a customer will purchase a product. There's more than one that is a classification problem, so you're looking for multiple. So we find out that only 2 of them weren't classification problems. And the way to figure this out is all of these other 4 are yes or no outcomes. We're classifying whether or not a patient has an illness, whether or not a stock will be more valuable next week. Rain or not next week is a binary classification as well. And then finally, predicting if a customer will purchase a product is either a yes or a no. So these are classifications. That's the end of the introduction video. Next time, we'll be covering exploratory data analysis, which can inform us on the best type of algorithm to use. Again, we're going to cover some terminology specific to EDA. And then finally, we're going to get practical in a code clinic using Python with a little bit of coding.